This is a presentation. I am part of the Archaeoastronomy Survey of Southeast Utah, which is an independent project in its 8th year of Jim Crable and myself. Very small team, I must say. So far, we have completed surveys at 179 sites. Our area spans pretty much most of the BLM land in Southeast Utah. So south of Canyonlands National Park, down to the San Juan River, from the Colorado border all the way over to Lake Powell. So lots of land. Most of our sites are rock shelter sites and canyons, so we have a few mesa top sites. Okay, so what do we found? Of those 179 sites, 86 show absolutely no evidence whatsoever of astronomical use. So a little under half. Of those 179 sites, 74 show evidence only of solar use. So solstices, winter and summer equinox, or cross quarters, halfway in between the equinox and solstice. 36 sites show both solar and lunar use, and 10 sites show only lunar use. So what I'm talking about when I'm talking about lunar use is lunar standstills. And show of hands, how many of you know what a lunar standstill actually is? Not very many. I thought I'd need to explain it. Okay, so starting with the solstices, so you have your axial tilt of the Earth, and that gives us the solstices. So up in the northeast to the northwest, you have your summer solstices. And then 6 months later, in December, you'll have your winter solstices. The moon, because of that axial tilt, does the exact same thing every month. So it's flying back and forth. Just moving. But that movement is complicated by the fact that the moon's orbit around the Earth is tilted, relative to the Earth's orbit around the sun. That tilt of about 5 degrees means that those lunastices, those turnaround points like the solstices, they change. So last year, 2015, was a minor standstill year. So those turnaround points, those lunastices, were inside the solstices. So the moon was moving back and forth a relatively short distance from north to south each month. But about March this year, that started to expand. Those lunastices started moving again. They'd been sitting for about a year at that minor, and now they're moving out. And for about 8 years, they're going to keep moving until they pass up the solstices and reach the major standstills, pretty far to the north and south. Okay. Couple notes on that. They don't look exactly the same each month. They happen for about a year each month, but they don't look exactly the same. Actually, the moon is moving so quickly back and forth that it actually moves about half its own width within the course of a day. So depending on whether you're watching it rising or setting or at what altitude, it'll look slightly different from month to month. So we have a little slop, if you will, in exactly what a lunar standstill may look like. Also, those orbits are determined by the center of the Earth, not by our position here on the edge of the Earth. So they're actually asymmetric about the standstills, or the solstices rather. So they're all shifted south from southeast Utah. So if you see that they're shown to be symmetric, they're not. They're actually shifted about 1.5 degrees, which makes a big difference when the moon's only half a degree across. Okay? So with that kind of groundwork, got a better idea now? A little bit better? Okay. With that groundwork, our results. They span from basket maker use all the way to Pueblo 3. Basically, we weren't really expecting that, but it covers all of that time span. We haven't checked Elk Ridge yet because it's on Forest Service land, so can't tell you about Pueblo 1, apparently. We have, let's see if I can read this, 23 major standstill sites, 10 minor standstill sites, and 17 sites that have both major and minor together. Of those, 19 are in the north. So again, moving back and forth from north to south. 19 are in the north, and 53 are in the south. That's largely skewed by the fact that we're looking mostly at rock shelter sites that face south. So you're not as likely to have northern alignments, period. So I can't interpret what that actually means. So what most of these look like is you have evidence of a place where that wasn't important at a site. So it might be a sit stone, it might be a kiva, some place where you know that they were paying attention to that place. And then from that specific location at the site, we survey the landscape. So we look for specific features on the landscape that seem to be important. And we look for whether the moon, those major and minor standstill places, line up with those features. How am I doing? Okay. So far what we've found is that the most common marker type, so where they're sitting at the site, or where they're placing themselves, or marking out at the site, the most common kind is a sit stone. So that's where you can tell that the texture of the stone is different. It's actually different than a grinding slick, I swear. We've managed to kind of discern the difference. 10 examples are from kivas, or ceremonial structures, clear ceremonial structures. 9 are from rock art locations. 6 are from non-kiva structures, architectural features. 4 are from geoglyphs, so just rock arrangements, kind of like what they were seeing, where was it? Down south, but with no clear architectural use. And 2 at where the entire site is far enough from the features that we can't really discern a specific place at the site that was important. And then the alignments they're looking at, most common is a hoodoo or boulder, so like the top of a hoodoo or the corner under a boulder. We have 18 of those. We have 13 points where the alcove ceiling comes around and meets the canyon rim. Usually that's in sites that don't really have landscape features. They resort to that more near-field alcove ceiling and canyon rim. We have 13 of those. We have 8 examples where it's a nose on the canyon rim. 5 examples where 2 canyon rims intersect. 5 where it's a divot on the canyon rim. 5 where it's the top of a butte or mountain in the landscape. 4 where there's a window between hoodoos or under hoodoos or a little arch, that kind of thing, a window feature. And 2 where it's an entire series of noses and divots that are being used. Okay, so a couple really standout examples. We have on Comb Ridge a rock art panel that is a crescent with a dot in the middle, recognizable as at Hopi as a Moon Clan symbol, the extinct Moon Clan. And from that, we actually have a canyon, alcove ceiling and canyon rim intersection where the major standstill moon rises. We have a large, about 3 meter diameter geoglyph on Cedar Mesa, and from the circular, and from the center of that, there's a small arch. Just kind of a flat surface with 2 little pillars, and the north major standstill moon sets straight through that from that geoglyph. We have a butte top site out on Cedar Mesa, some towers, a lot of potsherds, and directly from that, the south minor standstill moon sets onto Navajo Mountain. Pretty impressive. And one, I'm going to touch on the twins. There's a field house south of Canyonlands, and from that field house there's a pair of buttes, perfect twins in the mid-distance landscape, and the south major standstill moon sits dead between them. A beautiful thing. Or at least I'll see it in 8 years. I'll tell you if it's a beautiful thing or not. Okay, so a tiny bit of interpretation. There's not really any ethnography to tell us whether or not, for sure, people anymore are aware of the standstills. There's nothing there. But we can suggest, very tentatively, we do see that initiatory ceremonies at Hopi and in other Pueblo cultures, they occur, the winter initiatory ceremonies occur every 8 years. At least they're supposed to. They kind of let that lapse every now and then, but they're theoretically supposed to occur every 8 years. So potentially, that 8-year cycle was initially started as part of the 9-year major to minor standstill movement. So merely a theory, but could be.